Okay, so again, dA we can create by summing up all the 2 pi r's, where r is a variable. R is the distance from the center of the disk to some place, not quite A necessarily. So 2 pi r, the circumference of one of our disks, times dr, the thickness of that little disk. Okay, so now we need to make a substitution. So our electric potential is the integral of K sigma 2 pi r dr, and our r would be the distance from, well, if my little dq is here, it would be this distance right there, or this distance right here. If my dq was right there, yes, it's the hypotenuse, very good. Which would be the square root of what? X squared plus r squared. And we have to take that integral with respect to r, and we're going to sum it up from 0 radius to a radius of a. What do you think? All right, looks like we need to do what? U to U substitution. So what do we want U to be? X squared plus r squared. So then what's du? 2x dx? No. 2r dr. Yeah? Does that work? All right, so let's simplify our electric potential looking thing. I need a 2r dr, so that's kind of convenient. We can pull the k out, we can pull sigma out, we can pull pi out, and that'll leave me with the integral of 2r dr over the square root of x squared plus r squared. And this looks like du, and this looks like under here u. So now let's do a du over the square root of u business. So what's that going to give us? U to the negative 3/2? I think it's u to the 1/2. Yes. 2u to the 1/2. Okay. So now what do we do when we have to do u to u substitution? Put it back in. Yeah. So our k sigma pi. Who knew you would eventually be doing physics in terms of Greek letters? All right, so what was u? X squared plus r squared to the 1/2. So now we need to evaluate it from 0 to a, and the r we need to substitute in. So it's we can bring out this stuff that's constant. So we'll bring out a 2k sigma pi, and then x squared plus a squared to the 1/2 minus, now it's going to be r that's 0, so this will be x squared, I don't need that guy right there, to the 1/2. That's a 1/2. Sorry, it's so ugly. Yeah, so that'll just be x. So 2k sigma pi times x squared plus a squared to the 1/2 minus x. Is that right? That's the electric field. Does that look like an electric field that we solved for earlier? Nope, that's the electric